Good morning, children. Hope you're all healthy and safe at home. Let us continue with our section. We are going to discuss about higher order partial derivatives. In the last class, at the end of this section, we had discussed about partial derivatives. That is, given a function of more than one variable, we will treat or we'll derive that particular function by keeping one variable constant and differentiating the other with respect to normal rules of differentiation. So now what we are going to deal is, we are going to deal with higher order derivatives. So if you guys remember, in the last class, the example that we had done, we had found what was the derivative, partial derivative. If z was a function, we had determined dou z by dou x and dou z by dou y. So we can see that those two function values are clearly, again, they are functions of x and y. That is, dou z by dou x is a function of x and y, dou z by dou y is also a function of x and y. So we can again differentiate them partially. So you can see that the second order partial derivatives will be dou square z by dou x square is equal to dou by dou x of dou z by dou x. That is, we will again partially differentiate the function that we obtained, that is dou z by dou x in terms of x, and dou square z by dou y square is nothing other than dou by dou y of dou z by dou y. Then in a similar manner, we can find third order partial derivatives. How can we do that? Dou cube z by dou x cube will be dou by dou x of dou square z by dou x square. Why? This dou square z by dou x square will again be a function of x and y. So we can again partially differentiate it with respect to x and y. Now in terms of this partial derivatives, we can have mixed second order partial derivatives. How is that possible? That is, we have dou z by dou x. Now once we have dou z by dou x, I had stated that will be a function of x and y. So we can partially differentiate this function with respect to y also. That is, dou z by dou x is the function of x and y. We are partially differentiating it again with respect to y. So we get dou square z by dou y dou x. And similarly, we can partially differentiate dou z by dou y with respect to x also. That is, dou square z by dou x dou y is equal to dou by dou x of dou z by dou y. Now similarly, like we had done in the first order partial derivatives, we can obtain the second order and third order partial derivatives are denoted by fxx, fy by xxx, fxxx, and so on. And also for mixed partial derivatives, what do we have? We have fxy. That is, first term is x. So what is it? It is dou by dou y of dou z by dou x. Okay. The first one, that is fx, that is the first portion which will be in the bracket. That is, we have to partially differentiate the dou z by dou x with respect to y. And what will be fyx? Fyx will be none other than dou by dou x of dou z by dou y. Okay, just keep that in mind. Now we can note one thing is that if the second derivatives of the given function are continuous, then the second partial derivatives, the notation is irrelevant because both of them will be same. The second order, the function has continuous second partial derivatives, then the order in which the mixed second partial derivatives are written is irrelevant because both fxy is equal to fyx. Okay. So just like before, we can now move on to functions of three or more variables. That is, if w is equal to f of x, y, z in x, y and z directions, then what will be the derivatives? That will be dou w by dou x, dou w by dou y, dou w by dou z exist. So in a similar manner, how can we find? We can find dou w by dou x. How will we find dou w by dou x? We will find it by keeping y and z constant. Similarly, we can find dou w by dou y by keeping x and z constant and using the normal rules of differentiation. And now an example is given to us. That is, the function which is given to us is f of x, y and t. That is, the function is depending on x, y and t. So what will we get? We get it as the function given as e raised to minus 3 pi t cos 4x sin 6y. Then we need to find the partial derivative with respect to x, y and t. So how can we do that? To find the partial derivative with respect to x, we will keep y and t constant. So this term e raised to minus 3 pi t is a constant, sin 6y is also a constant. So we just have to differentiate the value cos 4x. What is the derivative of cos 4x? It is nothing other than minus 4 sin 4x. So what is fx of xyt? That is minus 4 e raised to minus 3 pi t sin 4x sin 6 pi. Then what will be fy of xyt? It will be cos 4x and e raised to minus 3 pi t will be treated as constant. So what is the derivative of sin 6 pi? It is 6 cos 6 pi. So the value would be 6 e raised to minus 3 pi t cos 4x cos 6y. Now next is to find the partial derivative with respect to t. So we'll keep x and y constant. That is the term cos 4x and sin 6y will be constant. We just have to differentiate e raised to minus 3 pi t. What is the derivative of e raised to minus 3 pi t? It is nothing other than minus 3 pi e raised to minus 3 pi t. So ft of xyt is minus 3 pi e raised to minus 3 pi t cos 4x sin 6y. So I hope it is clear. Just like we did the partial derivatives in case of functions with 2 variables, we can also find the partial derivatives of functions with 3 variables also. Now let us move on to the chain rule. I hope you guys remember we had discussed this in the earlier section also. So that is, we are given a function y in terms of u, that is y is f of u, and where u is another function which is differentiable in terms of g, that is u is g of x. Then how can we find dy by dx? Dy by dx will be dy with respect to du and du with into du by dx. Yeah. So the similar case we can apply for functions of 2 variables. We are going to use chain rule for functions of 2 variables. That is, z is given to be f of uv, where u is a function of x and y, v is also a function of x and y. So how can we find dou z by dou x? How can we find that? First we have to partially differentiate z with respect to u, then we have to partially differentiate u with respect to x, right? So it will be dou z by dou u into dou u by dou x. So it does not end here. Why? Because z is another z is depending on v also, so we have to consider that portion also. So we have to add with it dou z by dou v into dou v by dou x. So if we are considering functions of 2 variables, the chain rule will be as follows. If z is a function of u and v, where u is a function of x and y and v is another function of x and y, then dou z by dou x is dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. And similarly, what will be dou z by dou y? First we will partially differentiate z with respect to u, and then we'll partially differentiate u with respect to y. Then we'll add with it the partial derivative of z with respect to v into partial derivative of v with respect to y. So I hope it's clear. Now let us see an example. What is it? Z is given to be u square minus v cube, and u is e raised to 2x minus 3y, and v is sine x square minus y square. We are asked to find the value of dou z by dou x and dou z by dou y. So clearly we have to apply chain rule here. So let us try to solve this example. How can we do it? What are the functions which are given to us? We are given z is equal to u square minus v cube, u is equal to e raised to 2x minus 3y, and v is equal to sine x square minus y square, right? So what is dou z by dou x? By chain rule, first we have to partially differentiate z with respect to u, then again u with respect to x, dou u by dou x. But it's not over. Z is again a function of v also, so we have to do dou z by dou v into dou v by dou x. So let's see how we can do it. Let us find individual terms. So what is dou z by dou u? It is, we have to partially differentiate this u square minus v cube, keeping v as a constant. So what is the differentiation? Dou z by dou u is nothing other than 2u, right? And now what is dou z by dou v? Dou z by dou v would be minus 3v square. I hope that much is clear. Now we'll find what is dou u by dou x. Now dou u by dou x is dou u by dou x is nothing other than 2 into e raised to 2x minus 3y, right? Keeping y as a constant, we have to partially differentiate e raised to 2x minus 3y, that is 2 into e raised to 2x minus 3y. Now what is dou v by dou x? Sine x square minus y square. How can we differentiate? What is the derivative of sine? That is cos of x square minus y square. Then we have to differentiate x square minus y square. What is that value? That will be 2x. We are keeping y as a constant. So what is it? Dou v by dou x is 2x cos x square minus y square. So we'll substitute all these value. What do we get? We get 2u into 2 into e raised to 2x minus 3y plus dou z by dou v is minus 3v square into 2x cos x square minus y square. So you can substitute the value of u and v again. So in a similar manner we can find dou z by dou y. How can we do that? What will be dou z by dou y? First we have to partially differentiate z with respect to u, then u with respect to y plus dou z by dou v into dou v by dou y. Again do it in a similar manner and can obtain the value will be 2u into minus 3 e raised to 2x minus 3y plus minus of 3v square into, what will be the value of dou v by dou y? It is minus 2y cos x square minus y square. Here also you can substitute the value of u and v. So this is how we find the partial derivative of functions using the chain rule. So now just keep the notations in mind clearly. That is dou z by dou x will be dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. So next let us move on to the concept in which the functions u and v are single variable function. That is, in last case we had discussed u to be a function of x and y and v also to be a function of x and y. Here we are just going to consider u to be a function of t and v is also a function of t. So in this case what will be dz by dt? Dz by dt will be, that is we have to find the derivative of z with respect to t. So that will be z is function of two variables. So here we will apply partial derivative, that is dou z by dou u, and u is a function of t into du by dt plus dou z by dou v into dv by dt. Okay, so that is what happens when the functions u and v on which the value z is dependent are again functions of single variable. Now we can generalize this, that is, if z is a function of u1, u2, etc. un, and each u1, u2, etc. un are again functions of x1, x2, etc. xk. That is, u1 is a function of x1, x2, etc. xk, u2 is a function of x1, x2, etc. xk, etc. un is also a function of x1, x2, etc. xk. So what will be the value of dou z by dou xi? Here we are generally, they have given the general notation, that is dou z by dou xi is dou z by dou u1 into dou u1 by dou xi plus etc. dou z by dou un into dou un by dou xi. So what will be the value of dou z by dou x1? What will it be? Dou z by dou x1 will be dou z by dou u1. Then we'll partially differentiate u1 in terms of x1, that is dou u1 by dou x1 plus dou z by dou u2, then into dou u2 by dou x1 and so on, dou z by dou un into dou un by dou x1. Like that we can find dou z by dou x2, dou z by dou x3, etc. dou z by dou xk. And similarly, if these ui's are not functions of many variables but they are just functions of single variable, what will we get? We get dz by dt is dou z by dou u1 into du1 by dt plus dou z by dou u2 into du2 by dt plus etc. dou z by dou un into dun by dt. In this case, only for this function z we have to apply partial derivative. For all other functions it is single variable function, so we just have to apply normal derivatives there. So this is a bit clumsy, so to remember it easily we are introducing the concept of tree diagram. That's what the result in 5 can be memorized in terms of a tree diagram. How is it easy? First we will write the given function, that is z. Then we will see z is depending on two variables u and v. So we will write u and v again. And what is u depending on? X and y. V is also depending on x and y. So we will we will denote z, u, v, x and y and all these by dots, and then we will join them, that is z is depending on u and v, so we will join them. Z to u is joined by a line, z to v is joined by another line, then u is depending on x and y, so u to x we will join one line, u to y we will join one line. U and v there is no interconnection, so we are not joining any lines there. X and y also there is no interconnection, so we are not joining any line. And on all these lines we will write the partial derivative. So if we are asked to find dou z by dou x, what we do? We move vertically downward along this line. Dou z by dou x. From z we have to reach x. Okay, so what is it? Dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. Okay. So let us see. To compute dou z by dou x, we read the diagram vertically downward starting from z and following the two blue polygonal paths leading to x. We will follow all the paths leading to the variable x, and then multiply the partial derivatives on each path, then add the products. This is how we see the tree diagram. Now next is an example which depicts this tree diagram. It is very easy. You can see that we are given a function r in terms of x, y and z. So r is there as a dot, x, y, z is another, they are another three dots. Then you can see x is a function of u, v and s. Y is also a function of u, v and s. Z is a function of u, v and s. So again we will write x is a function of u, v, s. Y is a function of u, v, s. Z is a function of u, v, s. What are we asked? We are asked to find dou r by dou s. So we have to follow all the paths which lead to, which starts from s till s. What will be the partial derivative? It will be dou r by dou x into dou x by dou s plus dou r by dou y into dou y by dou s plus dou r by dou z into dou z by dou s. Let's just see it. What will be dou r by dou x? We have to keep y and z constant. What will the value be? It will be 2x. What will be dou x by dou s? U and v are constant. E raised to 2s. What is the differentiation of e raised to 2s? It is nothing other than 2 into e raised to 2s. So that will be 2x into 2 into u into v into e raised to 2s. Plus dou r by dou y would be, this is a constant, so this is 0, 5 y raised to 4 into z cube. And what is the differentiation with respect to dou y by dou s? What will it be? This is a constant. This will be minus 2v. With respect to s. So it will be minus v square. Okay. And similarly, what will it be? Dou r by dou z is 3 into z square into y raised to 5. And what is dou z by dou s? It will be cos uvs square into 2uvs. We have to differentiate this term also. So that is cos uvs square into 2uvs. This is how we find it. And the next example, you can try it on your own. That is depicting the z is depending on u, v and w, where u, v and w are just functions of t. So we just have to see how we can solve it. That is dz by dt will be nothing other than our dou z by dou u into dou u by dou t plus dou z by dou v into dv by dt plus dou z by dou w into dw by dt. So you can use it using tree diagrams, or if it is not comfortable for you, you can use our normal method also. You just have to remember the formula. How is it coming? That is, if z is a function depending on u and v, and u and v are again functions depending on some other more variables, you have to do the partial derivative accordingly. So that's it for today's session. Thank you. Stay home and stay safe.